follow the techniques. Same way, a redox reaction may be represented in complete form like this. This is called ionic form, where key ions, elements which are changing oxidation numbers only we put. But a complete equation is that all compounds in full. And in that case also, in same manner we must balance. But while doing that, we don't come across this charge balancing, because in that no charge species we put, everything is complete. But that advantage in one way, at the same time, okay, there is a big length we may notice in that, but that can be handled. But main procedure is same, that is observing the oxidation number changes and deciding the N factors to fix the ratio, number one. Then adjustment of the medium, acid or base depending on the situation. And finally adjustment of hydrogens and oxygens using water molecules. So almost every equation can be done in same 3 steps. But situationally small amendments we must do depending on the type of reaction. So for example, I will give you one small equation here, that is a complete form. Suppose potassium permanganate is known to react with oxalic acid H2C2O4 in medium like sulfuric acid to produce potassium sulfate, manganese sulfate plus carbon dioxide plus water. This can also be represented in ionic form, where permanganate ion, oxalate ion are the interacting substances. Mn2 plus manganese ion and carbon dioxide are the products. That is called ionic form. But just like in ionic form, in a complete equation also the balancing would be possible. And to do like that, same way, that is observing the changes in oxidation state and deciding N factors. Though the equation is looking lengthy, as we understood in previous discussions, we can pick up the key elements at once. Though there are plenty of elements found here, we can say here manganese and carbon are concerned, because manganese from plus 7 oxidation state is brought down to plus 2 state. Carbon in plus 3 oxidation state here, going up to plus 4 oxidation state here. So that all you should practice first to get oxidation numbers easily, and then come to this one. Here manganese changing from plus 7 to plus 2 state, indicating what here? Manganese is gaining 5 electrons, as we did in other occasion. Like that, how many manganese atoms in the whole KMnO4? Only 1. So this we call as N factor in this situation. Potassium permanganate's N factor in this reaction is 5. Is 5, and plus 3 carbons oxidation number plus 3 changed into plus 4. That says that carbon from plus 3 state went up to plus 4 state by losing 1 electron, undergoing oxidation. So its oxidation number change. But in the unit H2C2O4, like in KMnO4 you found 1 manganese, here in H2C2O4 there are 2 carbons. So N factor is 2. Notice how we find N factors carefully. Manganese is the element undergoing reduction by gaining 5 electrons. This is the change in oxidation state. This is the number of those atoms present in the whole formula. Product is N factor. Like that here, the change in oxidation state of carbon from 3 to 4 is 1, and then number of carbon atoms present in the unit, the whole formula oxalic acid is 2. So this is N factor. In that way, first decide N factors, then we get the concerned ratio. Like this, after you got the N factors of both, now simply exchange those N factors to fix the ratio. So I remove this which we used for the purpose of understanding the N factors. Now, as we know, its N factor 5 we got, its N factor 2 you got. Interchange 2, 5. That is a good start. With that, 90% work is over. When once you got this correctly, very carefully, finding the oxidation numbers clearly, and then understanding N factors and exchanging them, there ends main part. Okay, after that, immediately our response is that to adjust these atoms other side, because 2 and 5, these numbers we fixed. Other side we go, 2K, K2, yes, over. 2Mn, so 2Mn you make. And next, 5 into 2, okay, hydrogens, oxygens we do in due course. Carbons, 5 into 2, 10 carbons. So here you make it 10 carbons. 10 carbon dioxide. So main part is over. See, for these two we balance it, for these three already over. Watch carefully what left. H2SO4, H2O, only two substances. And this only earlier we said as acid medium, acid water. But there in ionic form H plus and H2O we use, but because the full form, the correct acid, whatever we use, sulfuric acid and water. So these are to be balanced. So just like in that, here also key steps are similar. First you understand the n factors, exchange them and get the ratio, and other side correspondingly give them the corresponding multiples to adjust the main atom, so that we will be left with the next step, just adjustment of hydrogens, oxygens, medium, acid, aqueous, medium. And in this step here, we must do slightly differently. In the previous ionic form, in adjustment of the medium, we counted the total charge and that we decided with number of H, adjusted with number of H plus ions or okay OH minus in basic medium. But here there is no charges. There is no charge here because it is a complete equation. So we must take the counterpart of acids. Sulfuric acid has H plus ions and sulfate ions. We used these H plus ions in the previous type of equations where ionic forms are used. But here it is a complete form where the sulfate ions account will help us in this way. If you see right hand side, K2SO4, 1 sulfate, 2MnSO4, 2 sulfates, and total 3 sulfates. Left hand side, sulfates to be provided only by sulfuric acid. Therefore, if you put 3 here, it is balancing. Now sulfates are equal. Last step, water. Always see that water is adjusted only at the end. I repeat, water should be adjusted only at the end. Then everything is comfortable. So now adjustment of hydrogens in form of water only. So left hand side count how many hydrogens are there. 5 into 2, 10. 3 into 2, 6. 16 H atoms. So right hand side also you must adjust this in such a way that 16 H atoms. Means here you see H2O I wrote here. So 8 H2O, it is balanced. So all hydrogens, oxygens, everything will be balanced. But while doing, follow a systematic procedure. Do not do by putting 1 here first and 2 here and trying, adjusting here and try it and trial way. Should never balance. Redox reaction should be balanced only in a systematic way, and that is by counting the n factors the best. That is nothing but oxidation number method. So here we are using that oxidation number method, and in this way we adjusted that. So that we can balance any lengthy equation also comfortably, and by that we can even remember the main things happening here. Oxalic acid is getting oxidized to carbon dioxide. The information can be well remembered. So only by this method one should practice balancing. So like this, number of examples we can practice, that assignment will discuss. But in other equations, when we go for further types of reactions, in redox reactions only, some more complications we come across, but those we have to overcome with small differences. But in all these, the major procedure will be identical. That is, starting with n factors and fixing a ratio, everything will be same. But order slightly we change. I mean, start we may make sometimes on right hand side. For example, in